Hey, I'm Tim DeStasio and this is Psychrometric Saturday, and today we're going to talk about the mixed air formula. A lot of times we're mixing two different air streams together. Those two air streams have different properties. So let's take, for example, we've got a typical air handler unit and we are mixing some outside air with our return air. So our return air conditions are 75-degree dry bulb, 55-degree dew point. That's our typical indoor design conditions. Our outside air conditions is 95-degree dry bulb way over here and 75-degree of dew point. So we got really hot, humid air coming in, and we're mixing those two air streams together. We're pulling in 700 CFMs of return air, and we're also mixing 100 CFMs of outside air. And when we add the two air streams together, we get 800 CFMs being delivered down to the space. Now, we have to understand when we mix those two air streams together, what is that mixture going to look like? And there's the mixed air formula, and it looks like this. You've got to take your return air temperature times your return CFM. You add that to your outside air temperature times your CFMs, and then you divide that entire number divided by your return CFM plus your outdoor air CFM. That's a lot of math. I suggest that you use some kind of calculator or an app. I'll be introducing a really good psychrometric app pretty soon that'll do that for you. But just trust me that the mixed air conditions are going to be here: 77-degree dry bulb, 58-degree dew point. And that really matters that we know that, because the difference between us plugging these numbers as actually hitting our cooling coil into manual S versus what our desired room temperature conditions are going to be into manual S could be the difference between us going up a size in the unit or not. Because as we add temperature and humidity to a unit, the performance of that unit will change. So it's always important that if we are mixing in outdoor air into the return, that we are plugging into manual S our actual mixed air temperature conditions. And that's the difference between us delivering air right here that's below the sensible heat ratio line, or delivering air that's just barely above it, where we start having comfort problems. So it's really important to know that information when you're designing a system. That's all for this time. Thanks for watching Psychrometric Saturday.